Welcome back to the series. Imagine this. You've loaded a ton of documents onto your LangChain pipeline. PDFs, text file, web pages, you name it. But now comes the big question. How do you exactly find the most relevant piece of information when the user asks a question? And that's where the retrieval comes into play. Retrievers are like the memory search engine of your LangChain system. They don't generate new information. Instead, they fetch relevant documents from your existing knowledge base. So whenever a user query comes in, the retriever looks at all your index data and returns only the chunks that are most relevant to that query. In simple terms, think of retrievers as your AI's librarian. You ask a question and it doesn't hand you the entire library. It quickly finds the exact pages or paragraphs that matters the most. Now, under the hood, retrievers often work with vector stores. Whenever you add documents, they're converted into vector embeddings, numerical representation that capture the meaning of the text. Then, when a question comes in, it's also converted into a vector, and the retriever compares it with all stored vectors to find the closest matches. This is how your system ensures semantic relevance. It's not just matching words but understanding the meaning. LangChain offers various types of retrievers. Some are simple keyword based ones, others are embedding based, and then others are even specialized ones like multi query retrieval or contextual compression retriever that enhances retrieval quality using LLMs. Retrievals are essentially big or retrievers are essential because they bridge the gap between your static document and your conversational AI. They ensure your LLM has contextually rich, relevant data to reason with without needing to retrain or fine tune the model itself. And in this video, we'll get hands on with one of the most commonly used retrievers, the Wikipedia retriever, where we'll see how to pull real time factual information straight from Wikipedia to enrich our AI response. So, now let's go to the video. Okay, so I'm going to create a new folder again here. I'll call it, okay, what is the size? Okay, 12. So let's me create a folder 12 dot retrievers. I'll create a new file inside this. Let's call it Wikipedia retriever.py. Okay, so from LangChain community.retrievers import Wikipedia retriever. Then I'm going to define my retriever object here. So retriever object R equals to Wikipedia retriever. I'm going to get the top key results and then the language. I can also say the language, and then the language has to be English. So my query is, let's say, Indian Premier League. And then what I can do is I can use my retriever object to invoke this query. I'm not sure how many documents I'll find, but let's print out the length of the document that I'm going to find here. So length docs. Let me run this. Okay, so I need to install Wikipedia. So let's go to a requirement, add a new library, save it. I'm directly going to install this without going to the requirements.py or other requirements.txt. So let me rerun this again. Where is that? Wikipedia retriever, yeah. So let me run this. It will take some time because it will again go to Wikipedia and then get the results from there. So yeah, this is my uh, since I've only asked for top two results, so it is giving me two results, and then for this one I can print each and every of my results. So for idoc in enumerate docs, what I can print is the results. So f result I plus 1, and then print content, and inside content I can print doc dot page content. Okay, so if I print this again, I will have my two documents as well as its content too. And then that is straight from some Wikipedia pages about this particular topic here. So this is how we use retrievers. In the next video, we'll see something else, or like we'll see more in the retriever section, and then we'll also use it on the local data or local document. So this is all for this video. I hope the implementation runs for your end, and I'll see you in the next video again.